Yeah. Kasama. Yes. Okay, welcome to today's paper. That is Kapsabet. That is paper 2, mathematics. We're going to look at section 1, running from question number 117. Now, in our previous video, we had some network issues, and we left. We had started this paper, but we left at around number 8 or something. So I'm here to start again and finish last section. So I'll start right from question, section, then we move together up to the last question in this section. So the first question was, we use logarithms correct to 4 significant figures to evaluate. That is the cube root of 24.36 times 0.066547 divided by 1.48 squared. 1.48 squared. So we are going to look at the logarithms of numbers. So it's number, log standard form, then number. So this is how we are going to write. I can use this color. So we're going to start with the number. Then we have form. Then we have log. Pattern. So the first number here, we have 24.36. 24.36. So with the 24.36, the standard form is 2.436 times 10 power 1. That means our log will start with 1 point. Then we'll look for the log over 2.436, and we shall have 38.67. So our log for 2.436 times 10 power 1 is 1.3867. Then move to the next number, which is 0.066547, and we shall have our 6.6547 times 10 power negative 2. So we shall have by 2 point, then the log over 6.6547, we have 8231. The two numbers we are multiplying, and the rules of log say when we are multiplying the two, we are going to add the results. So we add the two, we add the results, and we shall have it is 8, 9, then we shall have 0, 2.0. So we now move to the next part. That is 1.4. The next number is 1.48. 1.48. That is squared. So we have 1.4 times 0 point. Now the log of 1.48, 1703. 1703. But it is squared, therefore we are going to. So when we multiply by 2, we get 1703. We multiply by 2, we shall have 0.34. Remember, the numerator we are dividing, therefore we are going to subtract the 2. So this and this we subtract. This is what we are going to arrive at. So we subtract the 2, 0.3406, we subtract from 0.2098. So we are going to have this is, and then this is 9, 8. Then we shall have point. Now we shall have bar 1. Bar 1. Now this is now the results for numerator divide. Now we have that cube root. For us to deal with the cube root, we simply multiply or we divide by 3 or we multiply by a third. So when we multiply by, we now multiply by a third, and this is what we're going to get. So we extend our workings here, standard form, then you have the log. Now, so we shall have we multiply or we divide. Now we divide by a third. Now we have negative 1, or what we call it bar 1. We divide by 3. So what we do is separate the 2 so that we have negative 3, that is bar 3, divide by 3, plus we separate it into 2. Then we shall have negative 2.8692. We also divide by 3 because of the negative, that is bar 1. So when we have this, we're going to have a bar 1 now, point, that is negative 3 divided by 3, then bar 1.956, result of dividing by 3. Then each here we simply find the antilog. So the antilog of this, we are going to get whatever you're going to get, we're going to multiply by 10 power negative 1 because of this bar 1 times 10 power negative 1. So the antilog of 9564, we are going to get 9.045. Now 10 power negative 1, and we shall arrive at 0.9045. So this one now becomes the answer. So our answer becomes 0.904. That one. Then that one becomes your answer. Then you get your 4 marks. Then we move to the next question. Find the percentage error in the total length of 4 rods measuring 12.5, 24.5, 12.9, and 10.1, all to the nearest 0.0. So for us to calculate the error, we shall have a half of 0.1, which is plus or minus 0.0. So we look for the actual length. So the actual length becomes now what we have, 12.5 plus 24.5 plus 12.9 plus 10.1 plus, yeah, they're enough, therefore now. So these ones gives us 60.0 when you add the actual length. Then we look for the maximum length, whereby you're going to add in each, you're going to add the 0.05 maximum length. So the maximum length, we start with 12.5 plus 0.05, we get 12.55. Then we shall add plus 24.55, then plus 12.95, then plus 10.15. So in total, it gives us 60.20. Then we finally look at the minimum length. Now the minimum length is now 12.45 plus 24.45 plus 12.85 plus 10.0. So when you add the minimum length, you are going to get 59.80. 59.80. Now that one becomes our minimum length. Now we calculate the absolute error. First, to get the absolute error, we have to subtract the minimum length from the maximum, then we divide by 2. So we shall have 60.20 minus 59.80, and then you divide by 2. So percentage error will be equal to 0.2 divided by 60 times 100%. So we are going to arrive at 0.3% as our percentage error of the given measurings. That is how you get your 3 marks. And we now move to the question, which is number 3. So the third question, we have in the figure below, xt is a tangent. A tangent at Q. Then PXRT and QXS are straight lines. PX is equals to 6 centimeters. RT is then XQ qx is 4.8 centimeters and xs is 5 centimeters. So that is the figure. You can have a look at it. They're asking us to find the length of qt. Find the length of qt. Find the length of qt. So in this one, first of all, we look at xr, distance xr, distance xr. For us to get distance xr, we have to get xr, we have to get q, that is q x s, then we divide by 6, we divide by 6, then we now now for the distance qt after getting x. Now we find xr. For us to get xr, we take 4.8 times 5 divided by 6. 4.8 times divided by 6, we get what? We get 4. And then we take qt squared equals to pt times rt. You can see q squared, qt squared, this one is the same as pt times rt, the outer side, so that we have q equal to 18 times 8, so that qt 44 is equal to the square root of 144. So that qt becomes now square root of 144 is 12. So qt becomes 12 centimeters. So that is how we apply the rules to come up with the distance qt. To come up with the distance q. The next question, question number 4. With 7 coordinates to 4. So we have x and y. So we are given values of x. So we have negative 2, negative 0, 1, 2, 3,